In this segment, we will discuss how dyslexia manifests itself in other languages other than English. This slide is just a reminder of what dyslexia is. It is a neurological disorder that affects both decoding and encoding along with written expression. Most commonly, dyslexia is not a primary problem of reading comprehension or oral language. It is a problem with both reading and spelling words. So really think about word level reading and spelling words. In languages with shallow orthographies such as Spanish and Finnish, there is almost a one-to-one correspondence between individual speech sounds and the letters used to represent those sounds. And because of this, there is very consistent spelling. The regularity of the languages means that readers who are struggling or readers that have dyslexia are typically pretty accurate. They are just slow. So in these types of languages, dyslexia manifests itself more as an automaticity or fluency issue as opposed to an accuracy issue. This slide articulates the differences between the Spanish vowels and the English vowels and how those are represented in our language. So on the left, we have the Spanish vowels. There are 5 Spanish vowel sounds. And then below that, you can see the different spellings for how that sound might be represented. So for example, for the sound ah, the short O sound, we are always representing that sound in Spanish with the letter A. For the sound O in Spanish, we are always representing that sound with the letter O. So you can see that there are very consistent spellings for those vowel sounds. Unlike English, so in English, right away, we have 18 vowel sounds, many more vowel sounds in the English language. And if you think about the different ways that we spell these vowel sounds, we look at this, the long E sound. We can represent the long E sound with a single letter E, such as in me, with an EI, such as in receive, with an IE, such as in field. We can represent it with an EA, such as in bead. So there are many different spellings for a single vowel sound, making the English language a very deep language, as opposed to Spanish, that is a very shallow language. We also see differences in languages such as Chinese. So all writing systems must represent the speech sounds in a language, but the kind of speech sounds is not a constant. So in our English language, we are representing the individual phonemes in words with single letters or letter combinations. In Chinese, they represent whole words or phrases with symbols. So Chinese is a non-alphabetic language. So because of this, there's a heavy emphasis placed on symbols in this language. The symbols get very complex with the number of strokes, how those strokes are made, and it takes many years for readers and writers of Chinese to be able to write the language. Because of this, the Chinese language, the orthography or writing system is very cognitively demanding. So in a language like Chinese that is symbolic, dyslexia manifests itself more as a spelling or a writing problem in this language as opposed to in English. This slide is courtesy of Mary Ann Wolf. She is known for her work in cognitive neuroscience and psycholinguistics on the reading brain, language, and dyslexia. Unlike oral language, reading and writing are really inventions. The brain is not wired to read. It can rearrange itself in multiple ways to read depending on the writing system, the educational methods, and the medium. Oral language began around 200,000 years ago. Therefore, our brains have evolved naturally to acquire any language we are immersed in. This is unlike the writing system. The writing system and reading system was invented approximately 5,000 years ago with cuneiform, and really the Phoenician alphabet that the English language is based off of was invented around 1,000 years ago. So because of this, our brains have not naturally evolved to just acquire reading. We must receive instruction, and then our brain creates neural pathways to make reading the language effortless. These are examples of activation patterns in the English language as opposed to the Chinese language. So here again, we see these differences. In English, we know that language occurs on the left side of the brain. As someone takes in a printed word, the occipital lobe portion of the brain is activated. As they make connections between that printed word and the speech sounds, or how those letters and sounds work together, we see activation in the angular gyrus as they make sound to symbol connections. So all three of these areas are activated: the occipital lobe, seeing the printed word or the visual input; the frontal lobe, which is the phonological processing part of the brain; and then also the angular gyrus, where we are matching the sounds to the symbols. In Chinese, we see differences. So again, we see activation in the occipital lobe as a printed word, that visual input is occurring in the brain. And we see the frontal lobe where phonological processing occurs as we are pronouncing the word, but we do not see this activation in the angular gyrus where we're matching individual speech sounds to letters or letter combinations. So here we can see how, depending on the language, the brain rearranges itself to be able to read that language, and we see differences in patterns of brain activity.